I'm Anil Kumar, and in this video, we'll try to understand the connection between velocity and acceleration with the help of given graph. Sketch possible acceleration time graph from the given velocity time graph. So we are given a velocity time graph and we need to sketch acceleration time graph. As you know, acceleration A is actually rate of change of velocity. So we can always write this as change in velocity over change in time. So acceleration is indeed rate of change of velocity. So given this graph of velocity, we can find acceleration by calculating rate of change between different intervals. So you see these straight lines. So these straight lines will give you 1, 2, 3, 4 set of accelerations. So we'll find actually the slope, the rate of change from velocity time graph and get the value of acceleration. So in the first 5 seconds, we have time in seconds horizontal independent variable and velocity in meters per second as a dependent variable along the y-axis. So slope here will be meters per second divided by second, and therefore the units will be meters per second square, correct? So we'll have acceleration along the y-axis. Let us say this is acceleration and the units will be meters per second square, and here we will have time in seconds. So let's have the scale first. So we have 5 units, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, that makes it 10. So we have time 5, 10, 1, 2, 3, 4, 5, 15 seconds, 1, 2, 3, 4, 5, 20 seconds, right? That fits in. Now let's do some calculations and then figure out scale for the acceleration. Okay, so in the first 5 seconds, we see that the velocity increases from 0 to 10. So change in velocity in this is 10, right? 10 minus 0. So you can always find that change, which is final value minus initial value. Or we're trying to construct a triangle here. Let us say this is our triangle, right? And now we find this distance is 10 and time is 5. So 10 over 5 actually will give us the slope, which is 2, right? So in this interval we have acceleration of 2, right? Now let's calculate the acceleration in the next one. So we'll find the slope here again, right? Now in this case, change is from 10 to 30. That means this rise is 20, right? And the run here is 5 to 10. 10 minus 5 is 5, right? So we get 20 over 5, which is indeed equals to 4. Now in the third leg, velocity is constant. It moves at 30 meters per second for 5 seconds. So constant means zero change, right? So in this case, acceleration is 0, right? There is no change in velocity. Now in the third phase, what we have is velocity is dropping from 30 to 20, so the change is minus 10, so it falls by 10 units, right? Decreases. So it is deceleration in a span of 5 seconds, right? So that gives us minus 2. So these are different values of acceleration, right? Now let us plot these values. So we know we are going up to 4, right? So let us say that we have acceleration as, we'll use 2 units as 1. So this is 1 for us, 2 for us, 3, 4, 5, 6, right? So this is 1, 2, 3, 4, 5, 6, and similarly we have here minus 1 and let us say minus 2. So that is for acceleration. The units are meters per second square. So in first 5 seconds, there is a constant acceleration of 2 meters per second. So it is, so from here to here, it is constant 2 meters per second. So that is a horizontal line, right? And then we have from 5 to 10 seconds, we have a constant acceleration of 4. So from 5 to 10, the acceleration is constant, and it is 4 meters per second square, right? And then there is no change in velocity, and therefore acceleration is 0 from 10 to 15 seconds. And after that, there is deceleration, correct? Since it goes downwards, right? So now here in this particular case, it is minus 2. So minus 2 is the acceleration from 15 to 20, right? So that is negative value, right? So that is how we can actually graph acceleration versus time graph, right? So we have acceleration versus time from velocity versus time graph, right? So that is how it translates. So remember one thing, if we have constant increase in velocity, that means a constant acceleration, right? So rate of change for a straight line is the slope of that line, and that slope will be a constant. So that is how we can translate velocity time graph to acceleration time graph. Now we have 2 other videos where we will translate velocity time graph to distance time and displacement time graphs, and those are also very critical to understand. I hope and wish that you get time to go through all these 3 videos. Thank you and all the best.